Okay, in this video we're going to practice graphing in polar and also find the area of the region bounded by r equals cosine of 3 theta. So this is going to be a rose petal. It's 3 theta, so it's odd, so it's gonna have three petals. And so what we're going to do is we're going to graph cosine of 3 theta, kind of like we would have done in pre-cal or trig. And so we'll start off with that first. And I want to rig it so that I get the poles. So what I want to do is I want 3 theta, that to equal 0, pi over 2, pi, 3 pi over 2, and 2 pi, because those are my nice numbers on the unit circle. So dividing each one of those by 3, you get 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. And so when we construct our table like we do in trig, those are the values we're going to use. So 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. And we're going to go ahead and evaluate those in the cosine. You can check on your own, but these are the nice values. So these are going to give us the x-coordinates, 1, 0, minus 1, 0, and 1. And so we're going to go ahead and graph. This gives us one full period of the cosine. And I'm actually going to include a little bit on the left-hand side. I'm going to go to negative pi over 6, and that's going to kind of help us with the limits of integration here in just a moment here. So we throw in the negative pi over 6, and then pi over 6, pi over 3, pi over 2, and 2 pi over 3. And we'll go ahead and plot those points. And so there's our cosine graph, and it's going to continue its pattern going this way from 0 to negative pi over 6. And we'll also throw on a polar coordinate system here. So there's a number of things to do here. Things to highlight is this is going to be a maximum, and that's going to be a location of a petal. And that petal will be in the positive direction, so I end up choosing, we'll go out 3 rings to represent 1. So at 0, we're all the way out at 1. Okay. At pi over 3 here, at pi over 3, it's down at negative 1. So the directed distance is not going to put us here. It's not going to put us here, but it's going to direct us in the opposite direction. So we'll actually have the rose petal here. And that will happen whenever it is negative. It's going to go the opposite direction. And then at 2 pi over 3, we're back at a positive 1 here, and so we'll be up, somewhere about there. So that's where we're going with this. So we'll erase this stuff here. So let's go ahead and take a look. Okay, so there is 0 and 1. Now the cosine of 3 theta equals 0. So I'm going to go back and get those rose petals in a minute, but cosine of 3 theta is equal to 0. I'm finding where I cross the pole, and that's when 3 theta is equal to pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, etc. I only go out to 5 pi over 2. If I need to go further, I can include more. Divide all that by 3, and so that's going to happen at pi over 6, pi over 2, 5 pi over 6, and later I'll go ahead and show you that these are actually where we have tangents to the graph. So I've installed the radial line pi over 6, and I can actually get at that pretty quickly here. We're also going to hit 0 if 3 theta would be equal to negative pi over 2, and so dividing by 3, that would give us the negative pi over 6. And so that's going to actually line up with 11 pi over 6 in a minute here. Okay, so let's move this out of the way. So again, at the end of the video, I'll show you that that in fact is a tangent line, and those tangent lines are going to kind of help us graph the rose petal here. Then we'll install in a pi over 2, so we'll draw that radial line, and then 5 pi over 6, okay? Afterwards, it's just going to repeat itself, so those are going to help us with drawing in the rose petals. So I drew in one of the tips of the rose petals. The other ones, we're going to do the positive one right here, and that is 2 pi over 3. And then we also have one at pi over 3, but we got to go in the reverse direction. So it's not going to appear, let's use green. So it's not going to appear here because of the negative. It's going to send it, it's going to reflect it over this way. And those are going to be the peaks of my petals there, or the furthest out my petals go. And I'm actually going to use my graph here, and that's going to help out with sketching the curve here. So at 0 radians, we're out at 1. And then as we approach pi over 6, our graph is going back to 0. So we'll start out at that point over there on the right, and we'll start curving in towards the origin. Okay? Now, between pi over 6 and 3 pi over 3 right here, the problem with this is that's all negative, and so all of that stuff is going to be shot down here because of the fact that it's negative. That's how the polar coordinate system works. And so we're going to curve down, and then we'll come back to the origin. And when we hit the origin is when we curve all the way back up, and not only from pi over 6 to pi over 3, but also pi over 3 to pi over 2. So all this stuff would be down here, and that's where you see this curvature right there. And then once we get to pi over 2, then it's going to be positive, so it's going to behave normally. It's not going to be reflected. And we can say that, oh, well, this graph is going to continue doing its thing, and it's going to crash back down. So it comes back down on itself, and it'll complete the whole cycle there. And that finishes our rose petal there. Oops. Uh-oh. We broke the rose petal. Let's try to sketch this in real quick. Sorry, I was trying to get rid of my green highlighted, and I broke it. All right. So there's our rose petal. Now I end up talking about how to kind of go with those limits of integration, and the key is looking at this part right here, and that part corresponds to that part of the rose petal. Okay. All right. So I've highlighted in green, and we'll highlight it again. Maybe we'll highlight it in, I don't know, orange. So this portion right here that I'm highlighting, that corresponds to this part right here, and that's from negative pi over 6 to pi over 6. That gives us that rose petal right there. So that gives us our limits of integration. There's another way we could do this. This is going to be the easiest way. So our limits of integration are going to be negative pi over 6 to pi over 6. Okay, so that's how we establish. So we're not going to use 11 pi over 6. We'd have to extend this out a lot further to get to 11 pi over 6, and we would go from 11 pi over 6 to we'd have to go pi over 6, so that'd be 2 pi, and then 13 pi over 6. We'd go 11 pi over 6 to 13 pi over 6. That'd be the other way we'd do it. But we'll try to keep things related to our graph here. That seems to make things a little easier. Okay. And so we're going to go on and we're going to integrate. So the area formula for polar coordinates is 1/2 alpha to beta. Whatever your formula is, squared d theta. That's 1/2 alpha to beta r squared d theta. Our limits of integration were negative pi over 6 and pi over 6. Okay. And our function was r equals cosine of 3 theta. We're going to go ahead and make a note. We use a pretty extensive, we use this fairly often, this power reducing formula. because I don't know what the antiderivative of cosine squared is. So I use my power reducing formula to write cosine squared as 1 plus cosine 2 theta. So whatever your angle is, you're going to double it. So we're going to end up doubling 3, and that's going to give us a 6. So the cosine squared of 3 theta, that's going to be equal to 1 plus the cosine of 6 theta all over 2. And what we've done, and usually what we do with these types of things, we're finding the area bounded by a figure is it's going to be symmetric, so each one of the petals is going to be the same. And so we find the area of one of the petals, and then however many petals there are, we just multiply by that number. So this is where that 3 is coming from. Since there's 3 petals, we're going to find the area of one petal and just multiply by 3. So 3 over 2, negative pi over 6 to pi over 6, and then cosine squared of 3 theta d theta. We'll go ahead and use that power reducing formula. So here you're going to have a denominator of 2, so that's going to join this 2 here, and that's going to make a 4. So we're going to have 3 over 4 outside the antiderivative, or the integral, negative pi over 6 to pi over 6, a 1 plus cosine of 6 theta d theta. And now we're ready to integrate, so 3/4 theta plus sine of 6 theta over 6, evaluated from negative pi over 6 to pi over 6, okay? And I'm going to simplify this down a little bit. When I plug in pi over 6, I'm going to get pi, and the sine of pi is 0, so that's not going to contribute anything. Likewise, when I plug in negative pi over 6 into the theta, I'm going to get the sine of negative pi, and that is also 0, so that's not going to contribute anything. So essentially what it's going to be is 3 over 4 times pi over 6 minus negative pi over 6, and that's going to equal to pi over 4. So that's the area incorporated into those 3 rose petals there, or bounded by that rose curve. So the other thing that I mentioned that I haven't done yet is actually demonstrating that those were tangent lines, the pi over 6, the 5 pi over 6, and the pi over 2. So we'll go ahead and mention that also. And so if we have a tangent line, what we need to do is we need to find where our function equals 0. That means where it's crossing the pole, so we actually have a tangent line through the pole. And then the derivative is not 0. Then the theta, that radial line, is a tangent line to the graph. So for our function cosine of 3 theta, we already found where it crossed the pole. And that occurred when theta was pi over 6 and pi over 2 and 5 pi over 6. And we could actually go further and be 7 pi over 6, 3 pi over 2, and 11 pi over 6. And we could keep going. And how we got these is, well, the cosine is equal to 0 at pi over 2, and then 3 pi over 2, and then 5 pi over 2, and then 7 pi over 2, 11 pi over 2. 11 pi over 2? No. We're almost there. 9 pi over 2 first. Okay, 9 pi over 2. And then 11 pi over 2. And then if we divide this by 3, then we divide all these by 3. So essentially you're going to be multiplying your denominator. So 2 times 3 is 6. The 3's would absorb, so you'd have pi over 2, and then you get the 6 here, etc. So let's erase all of this mess. Okay, etc. So now we got to make sure that these are not 0. So the derivative is, with respect to theta, is negative 3 sine of 3 theta. So install the pi over 6 and the pi over 2 and the 5 pi over 6, and that's enough. And they all are not 0, so that's our verification that those are in fact tangent lines. So So it takes a little bit of practice. If you know your trick real well, and you can do a nice graph, it'll make things a little bit easier. It just takes practice. It's not terribly difficult. I'll probably end up making another video or two. Try to do some of more examples.